Alright, today's lesson is 7.7 base E and natural logs. So like pi and the square root of 2, E is an irrational number, 2.71828, repeating forever. It is referred to as the natural base E. Alright, so an exponential with base E is called a natural base exponential function. So we have a function that looks like this. E to the x and e to the negative x. So in red is your e to the x. This will look like graphically. Its inverse is this green line here. Okay, and that is natural log of x. ln is natural log, which we'll talk about more in a minute. And on the right hand side, we have e to the negative x. So this is like a decaying exponential function. And its inverse is the natural log of negative x. As we learned before, the inverses are just reflection over the line y equals x. So what we have here is the natural log of 4 is equal to x. So this becomes log base e of 4 equals x, which then becomes e to the x. So another way to look at it a little more simply is log base e becomes natural log. Okay, we say it as natural log. Alright, so we're going to write each exponential function in log form, example 1. So in A, we have e to the x equals 8. So remember, we have y equals b to the x. And this can go back and forth to log base b of y equals x. Okay, so this is we started learning at the beginning of the unit, and it's just going to continue on. So I have log base b, which would be e in this situation, of y, which is 8, equals x. Now log base e is natural log, so we write natural log of 8 equals x. Okay, simple as that, and we're just converting, we're not evaluating. Alright, and then for b, we have e to the 5 equals x. So log base e of y, so that's the rx, equals 5. So the natural log of x is equal to 5. Now we're going to take example 2. We're going to write each log into exponential form. So I'm going to write as log base e of x is equal to 0.7741. So b to the x means we got e to the 0.7741 is equal to x. So again, that's my b, that's my y, that's my x. Alright, so b is the natural log of 10, so log base e of 10 equals x. Okay, b, y, x. So b, I'm actually writing b, sorry. So b is e, so e to the x, right? Yep, is x equals 10. So e to the x equals 10. Boom, converted. Example 3, we're going to use our properties from the previous lesson, and we're going to condense each logarithm. So the number out front of 3 natural log of 10, this goes into the power, so you get natural log of 10 cubed minus the natural log of 8. Remember, subtraction becomes division. So we're at the natural log of 10 cubed over 8. The natural log of 10 cubed. 10 cubed is 1,000 divided by 8. So this becomes the natural log of 1,000 divided by 8 is 125. Again, don't evaluate, we're just rewriting. So for B, I'm going to use my power property. The number in front becomes the exponent. So the natural log of 40 plus the natural log of 1/2 squared plus the natural log of x. Alright, so 1/2 squared is 1/2 times 1/2, which equals 1/4. So we have the natural log of 40 plus the natural log of 1/4 plus the natural log of x. So remember, addition becomes multiplication. So we have the natural log of 40 times 1/4 times x. So 40 divided by 4 is 10, and x stays as x. Alright, example 4, now we're going to solve these equations. So we have 4 e to the negative 2x minus 5. What we want to do is isolate the e. Alright, so I'm going to add 5. So do my SAD map. So algebra hasn't changed here. So 4e negative 2x is equal to 8 divided by 4. So we get e to the negative 2x is equal to 2. Alright, to get rid of this e. Alright, so I'll make a note over here to get rid of e. Take the natural log of both sides. Alright, take the natural log of both sides. So I'm going to get the natural log of e to the negative 2x equals the natural log of 2. The natural log of e cancels. Alright, so this happens right there. So then now we're just left with the exponent. So you get negative 2, wrong color. So negative 2x equals the natural log of 2. Divide by negative 2. So we get x equals, now in the calculator just plug in the natural log of 2 divided by negative 2. And we're going to get negative 0.3466. Alright, so the big thing is to get rid of the e, you take the natural log of both sides. That's like when we did in the previous lesson, you take the common log of both sides. Alright, example 5, part A. We're gonna solve 3 natural log of 4x equals 24. Alright, so what I want to do here is I'm going to divide by 3. So natural log of 4x is equal to 8. Dun, dun, dun. So I'm going to isolate natural log. Alright. So now we're stuck. We got to get rid of the natural log. So to get rid of, we're going to take e of both sides. So this becomes e and e. So this becomes e to the natural log 4x equals e to the 8th power. So pushes that up into the exponents. Okay, so what happens is e to the natural log cancels out. So now we're left with just the exponent there. So you have 4x equals e to the 8th power. I'm going to divide by 4, because remember, e is just a number. So in the calculator, I'm going to put e to the 8 all divided by 4. This gives me 745.2395, because we are rounding to 4 decimal places in this unit. All right, for B, we're going to change this problem. Make it just equal sign, so I don't have to worry about anything. It's end of the year, so it's not a big deal. All right, now we're just going to solve. So I'm going to first take this exponent and I'm going to put it out in front. So 4 natural log x minus 8 equals 4. Isolating the natural log, we'll divide by 4. The natural log of x minus 8 equals 1. All right, remember, so now we're looking at a, we're going to take the e of both sides. So this becomes e natural log x minus 8 equals e to the first power. E and natural log cancel out. Left with x minus 8 equals e to the first power. So I'm going to get x equals e to the 1 plus 8. Again, just putting that in the calculator, I'm going to get x equals 10.7183. We are done. All right, so finishing up on the little word problem. So when Angelina was born, her grandparents deposited $3,000 into a college savings account, paying 4% interest compounded continuously. Assuming, typo, there are no deposits or withdrawals from the account, what will the balance be after 10 years? So this is money just sitting in the account, compounding on itself, nothing's being added. So we're given the formula A equals PE to the RT power. All right, where A is our final amount, P is the initial amount, okay, E is the number, and R is rate, T is time. So A, we don't know. Our initial amount was $3,000. Our rate is 4% or 0.04. And time is 10 years. So let's plug in and solve. So A equals 3,000. E 0.04 to the 10. Alright, just hammer that out in the calculator. So simplify one more step. E to the 4% of 4. Sorry. Is 0.4. So A equals the end of it put in the calculator is 4,475 and 47 cents. So not a huge amount, but still something, just money just sitting there. Alright, so the flip of this, so some of our problems before is, how do we earn? Like, what do we need to do to get $10,000 in this account? So A equals 10,000. We don't know the principal. The rate is still 4%. And then we don't know time. I lied. We know the principal. We're still putting 3,000 in. We gotta figure out how long it's gonna take us to get $10,000. So we have 10,000 equals 3,000 e to our rate times time, and we solve. So divide 3,000 from each side. This gives me 3.3333 because we're doing 4 decimal places. E to the 0.04 t. Now again, we want to get rid of e, so we have to take the natural log of both sides. So the natural log of 3.333. Remember, the natural log in e cancels out, so we're about to 0.04 t. Divide by 0.04. Okay, so put that in the calculator. So t equals 30.10 years. So 0.10 years is 0.1 times 12. So roughly 30 years. 30 years and 2 months. So if her grandparents want her to have $10,000 after 18 years, how much should they invest? So our principal is the unknown here. So we want 10,000. We don't know our principal. We know our rate is still 4% and time is 18 years. So let's solve this. 10,000. P to the 0.04 times 18 is 0.72. And we're e's a number, so I can just divide by e to the 0.72 power. Alright, so I put everything in parentheses if you're using calculators or whatever calculating devices you're using. So 10,000 divided by e to the 0.72 is equal to 4,000. Sorry if you heard my belly rumbling. I haven't had breakfast yet. So to initially put in $4,867 to have 10 grand after 18 years. Alright. There we go. Alright, email me if you have questions on the assignment.